processing or accessing two-dimensional arrays. When we discussed the processing one-dimensional array, we used a single for loop. The variable loop was used as an index variable to the array. We visited the elements of the array either from left to right or from right to left. From left to right, we start with index 0, 1, 2 until the last index. And from right to left, we visit the elements from the last index and all the way down to index 0. Now, if we have two-dimensional arrays, then we have two dimensions. One dimension is for the number of rows, and the other dimension is for the number of columns. Therefore, we need also loops to process the array, but this time we need nested loops. When we say nested loops, it means a loop inside another loop. So we have outer loop and we have inner loop. Now it makes a difference how we process the array elements, because we need to do it in a systematic way. For one-dimensional array, the systematic way is to visit every element one after the other using a loop variable that is incremented by 1. As we said, either from left to right or right to left. Now for two-dimensional arrays, how to do that? There are two ways. Either you visit the elements row by row, or you visit the elements column by column. Now to visit the elements of the two-dimensional array row by row, this is how it is done. First, you visit the first row, element by element, from left to right, or maybe you can do it from right to left as well. And then you finish from the first row, then you go to the second row, also from left to right. Once you finish from the second row, then you go to the third row, fourth row, so you are visiting the array elements row by row. The other way to process the array is by visiting the elements column by column. So first you visit all elements in the first column. Once you finish, you go to the next column. Once you finish, you go to the next column until the last column is processed. Now for row by row, as you see in the animation here, that we are visiting the elements from left to right. But you can also visit the elements from right to left. But the point here is that you need to visit the elements row by row. Likewise for column by column, we are visiting the columns from start until the end. But you can do backward as well. But the point again is that you need to visit every column one after the other. After understanding how to process or access two-dimensional arrays elements in a systematic way, either row by row or column by column, now is the time to see how to implement that in a Java code. We are going to use nested loops, so programs that process two-dimensional arrays can do so with nested loops. Again, what does it mean by nested loop? It means you have a loop inside another loop. We have an outer loop and we have an inner loop. To determine the processing type, either row by row or column by column, it is determined by the outer loop. If you write the outer loop that counts number of rows, then we are processing the array row by row. And if you write the outer loop for the number of columns, then you are processing the array column by column. Of course, if you make one loop for one dimension, you have to make the other loop for the other dimension. So if the outer loop is for the rows, then the inner loop should be for the columns and vice versa. So let me show you how to implement this in a Java for row by row processing. For row by row processing, imagine we have a two-dimensional array called scores of integers. It has 3 rows and 4 columns. Now we have nested loops, so we have a for loop that has another for loop inside it. If you want to process the array, the two-dimensional array, row by row, then make the outer loop responsible for counting the number of rows. This is why we are labeling the for loop variable as row, to tell us that this loop is responsible for number of rows. So notice how the index variable, it is going from 0 until the length of scores. And remember that if we use the instance variable length on the name of the array, it will give us number of rows. So in fact, this loop is counting how many rows do we have in the two-dimensional array. The inner loop inside is responsible for the number of columns. And remember that each row is in fact a one-dimensional array. And if you define an array this way, then this is not a ragged array. That means the size of each one-dimensional array in a row is the same. So you can use the length for this one-dimensional array to specify the number of columns in the inner loop. So when you write scores row, if row is 0, then you are referring to the first dimensional array. And if you use dot length, then it will give you the size of this one-dimensional array, which is the number of columns. Now, if you go to the next row, row equal to 1, then you are referring to the second one-dimensional array. And again, if you use dot length, then that means you are determining the number of columns. Notice here that this could work also for ragged arrays, because in every row, we are referring to a different one-dimensional array. Then every one-dimensional array will have different size, so the inner loop can handle these elements one by one. After determining the two loops, then in the inner loop, how to reference the element of a two-dimensional array. Remember, for any element, it needs two indices, one for row and one for column. It is always the first dimension is referring to the row index, and the second dimension is always referring to a column index. So it doesn't matter which loop you are using, inner loop or outer loop, the first dimension should refer to the variable of the loop that is responsible for number of rows. Now in these two nested loops, the outer loop is responsible for number of rows. What is the variable we are using for this loop? It is row. So you have to use this variable as an index variable for the first dimension. You cannot use it for the second dimension. Even if we don't label it row, you should know which one to use for the first index and which one to use for the second index, because the loop determines the bound for the dimension, so it will not exceed the bound of this dimension. Therefore, the variable row is used for the first dimension because this is the variable used for the loop that is responsible for counting number of rows, and column variable is used for the second dimension because this is the variable used for the loop responsible for counting number of columns. So it doesn't matter if it is outer loop or inner loop, just look for which one is responsible for row, use its variable for the first dimension, and use the other variable for the second dimension. Now to process every element of a two-dimensional array, column by column, then we are going to use also nested loops. But this time, the outer loop should be responsible for counting number of columns, and the inner loop should be responsible for counting number of rows. Now, since every row in a two-dimensional array is in fact a one-dimensional array, so we can use this one-dimensional array length to determine the number of columns. We are defining a two-dimensional array, number of rows is 3, and number of columns is 4. This is not ragged array. So that means every one-dimensional array of a row has the same size. You can use any one-dimensional array of any row to determine the number of columns. Therefore, we are using dot length for the array that is at row 0. So we say score 0 dot length. You can also use the length for the array at row 1. You can say scores 1 dot length. Because every row has the same number of columns, so you can use any one of the dimensional arrays of any row to tell you the number of columns. Now the inner loop, you have to make it count number of rows. And remember, if you use dot length, the instance variable on the name of the array, it gives you the number of rows. So therefore, the outer loop is responsible for counting number of columns, and the inner loop is responsible for counting number of rows. Now notice which loop is responsible for counting number of rows. It is the inner loop. So what is the variable name? It is called row. So use this row for the first dimension. And which loop is responsible for counting number of columns? It is the outer loop. What is the name of the variable? It is called column. Use it as the second dimension. As a conclusion, if you have nested loops, then look for the loop that is responsible for counting number of rows. Use its variable as an index for the first dimension. And look for the loop that is responsible for counting number of columns. Use its variable as an index for the second dimension. It doesn't matter that this loop is outer or inner loop. All what matters is that which one is responsible for counting number of rows. Use its variable as the first dimension. And if it is responsible for number of columns, use it as the index for the second dimension. As a final remark, if we have a ragged array, then we can process this array row by row. However, it is very difficult to process it column by column. Why? Because the size of columns is not the same. So for the outer loop, what we should use for the number of columns? Because each row has different number of columns, so it is not easy or straightforward to process such array column by column.